Hi everyone, I'm Anish and welcome back to PrepFusion. This is the lecture 6 of frequency response using polar plots basically. So here, right, we'll do few questions on gain and phase margin and other relative stability parameters, right? The questions that I gave you in homework. But before going to the questions, let's quickly recap of what we did in the last lecture, in the lecture 5 basically. Basically, I told you about two relative stability parameters, that is the gain margin and phase margin, right? So from the diagram itself I can understand, like here, right, what is gain margin? It is the reciprocal of the magnitude of my OLTF at phase crossover frequency. Okay, what does this signify? Basically the additional amount of margin left for it to become unstable. Okay, if it reaches -1, if the OLTF, right, reaches -1 at that point, when my phase is -180 degrees, then obviously my system will become unstable, right? I hope you got it, right? There will be some phase crossover frequency, and if there is some phase crossover frequency, like it is like my poles of the CLTF are lying on the imaginary axis, hence it will be obviously marginally stable, and just after that it will go to instability. It is on the verge of instability. Okay, so yeah, this is what my gain margin is. And what is the thing to remember here is gain margin is a function of omega p, right? It is related with phase crossover frequency and not with gain crossover frequency. So it is very important. Okay, very important. Okay, gain margin is related with phase crossover frequency and not with gain crossover frequency. Okay, so yeah, this is this one. Now, like in dBs we got it. And what about my phase margin? So the phase margin is the additional amount of phase lag that needs to be added to the phase of the system, right, at omega equals to omega g. So it is basically the additional amount of phase lag that is needed to be added to the system at omega equals to gain crossover frequency. Okay, so I should write this as gain crossover frequency. Okay, so write it as gain crossover frequency, right? So that is what my like phase margin is, the additional amount that I needed to shift it, right, to shift that like whatever point to the negative real axis to -180 degrees, right? So what is the additional amount of phase lag, right? That's why I'm shifting it in clockwise direction. That's why this is a negative angle, but we don't show it negative, we just show it positive. But internally we know this is a phase lag, right? This is a clockwise direction angle, right? Okay, that is internally known, right, to move it to the verge of instability. So my phase margin is obviously function of gain crossover frequency, right? It was gain crossover frequency and not of phase crossover frequency. Very important point to note. It is a function of gain crossover frequency, not of phase crossover frequency. So generally we will tend to get confused, right, between gain margin, phase margin, because we will have four things, right? Gain crossover frequency, phase crossover frequency, gain margin, and phase margin. So in between these four things, what happens is we generally tend to get confused. To not get confused, we write like this one, right? So like to understand, right, what is function of this one, so you can put this in your short notes to quickly revise, right? So you can put all these things, right, in your short notes. Okay, so that you can recall easily what you studied, right, in the long lecture. So if the OLTF does not have any poles on zeros on the right half plane, like, and if my gain margin and phase margin are both positive, then the system will be stable. How? We'll understand, right? I'm not going into this point any deeper. But if my poles, right, if they lie on the left hand side, right, if they lie on the left hand side, then obviously this will decay, right, and I will be only left with this sinusoidal response. Okay, I'm giving a sinusoid input and I'm getting a sinusoid response. That is fine, but what happens if my poles, right, they are on the right hand side, right? If they are on the right hand side, right, then what happens? Obviously this exponential term will not decay. Okay, I'm not interested in the exact form, just I'm giving you some form, right? This form here, exponential term will not decay. And if the exponential term doesn't decay, then what happens? Then obviously this will keep on increasing, right? This will keep on increasing, and this term will dominate over this term, and hence at steady state my output isn't bounded anymore for a sinusoid input, right? It is unbounded. So that's why my system becomes unstable. Okay, response unbounded. So yeah, that's what we did. And from here directly graphically we can understand what is my omega gc, what is my omega pc, what is my phase margin, and what is my gain margin. Tell me here, what is my omega gc? Omega gc is the point at which the distance from my origin is 1, right? The frequency at that point where my distance from the origin is 1 of that polar plot, basically with the help of polar plot. So here this point is basically the point where the frequency at this point is my gain crossover frequency, because the gain is 1. Again, what is my phase crossover frequency? pretty much easy, right? So gain crossover frequency, there is another way to find it out. Basically, you draw a circle of unit radius, right? This picture is not representing it correct. You just draw a circle of unit radius, then the point at which this polar plot cuts the unit circle, right, which has center 0,0, that point is known as my gain crossover frequency. Basically, point like the frequency at that point is the gain crossover frequency, because the magnitude, the distance from the origin of that point is 1, right? Because circle has always distance from the origin 1. So yeah, that is my gain crossover frequency. That is done. What are my phase? Pretty simple, right? Phase is like where my polar plot cuts the negative real axis. If my polar plot cuts the negative real axis, that point is basically minus 180, like phase crossover frequency, because the phase of my polar plot of my OLT at that point is minus 180 degrees. Simple. Okay, that is my phase crossover frequency. The frequency at that point is my phase crossover frequency. Now what about my phase margin and what about my gain margin, right? So gain margin is related with omega pc, so it will be here, right, not here. So gain margin is the amount of gain, like amount of margin that I have left, so that I can move this one here, right? So x is the margin, right? If I multiply x with this gain k, then I will get gain of 1, overall gain of 1, right? So this point will get shifted over here. I want to shift this over here to understand that how much room I have left, so that still my system remains stable, right? Still my system remains in the stable region. Okay, how much room I have left for my system to still be remaining in stable, right? Still it is remaining in stable. Okay, so yeah, this one is this one. Now what is happening next? So this is about the gain margin. So here, right, I prove the gain margin, right? I'm not going to much details. So again, what is phase margin? Now phase margin is related with the gain crossover frequency. So here, right, I have gain crossover frequency. Now what do we need to do? Basically I need to shift this one to, like, this is already 1 magnitude. So if I shift this one to the real axis, negative real axis, then the phase will also be minus 180 degrees, right? And the gain is already 1. Okay, the gain is already 1, not the gain, basically the magnitude of the OLTF is already 1, right? Magnitude of OLTF is already 1. So again, right, I will reach the critical point. Main thing what I am doing is trying to reach my critical point. What is the critical point condition? The phase of the OLTF should be minus 180 degrees, and the gain should be, the magnitude of my OLTF should be 1. So anywhere, right, if I say gain, right, just try to understand I'm talking about the magnitude. Don't get confused, right? If I say gain, that means I'm talking about the magnitude of OLTF, because it is a big word, right? So that telling it every time is a bit difficult, right? So yeah, that is about my gain. That is about my magnitude of OLTF, right? So yeah, if I shift this point here, the magnitude of OLTF is still 1, and my phase this time becomes minus 180 degrees. My phase this time becomes minus 180 degrees, right? So this is what about my phase, and this is about my this is about my phase margin. How much margin I have left? Still it is remaining. Phase margin I have left, still it is remaining stable, right? If it reaches that critical point of minus 1,0, then system will become unstable, right? Unstable. So yeah, that is what I am mainly interested in, right? So just wait, let me check if everything is recording or not. Yeah, everything is recording, that is fine. Good. Yeah, this is about my phase margin and gain margin, right? Okay, briefly I have explained everything, right? So yeah, then we took one example and how to find it pretty quickly, right? Like if, like, that one magnitude of OLTF 1 is lying between these 2 points, right? Then, like, obviously omega GC exists, right? Omega GC exists because, like, this is a continuous function. Obviously, as this is a continuous function, then 1 will be here. It can't just suddenly avoid 1, right? This is a continuous function. This is an analog function, hence it is continuous, right? That's why. So, and this, right, here, right, I cannot surely say that, like, omega p will exist or not. Okay, I cannot surely say. That's why here I can surely say that omega GC will exist and will proceed, right? Here I cannot surely say omega PC, like, or omega phase crossover frequency will exist or not, because what happens is that there may be some condition, like from plus 90 it may, like, it may go to minus 180, then it may come back to plus minus 90. It may so happen. How? We'll see a few examples, there will understand. Okay, yeah. Yeah, but in between these points, obviously there will be, like, it will cover all these points, right? Between plus 90 to minus 90, obviously it will cover all the points, but it may so happen, it may also cover minus 180 point that I can't find from here. Okay, for that, obviously you follow the procedure, right? Simple procedure. You make the magnitude of OLTF equals to 1 and you get directly the omega GC. If you are not getting omega GC, valid omega GC, then definitely omega GC, basically the gain crossover frequency, doesn't exist. Okay, and here, right, you make the phase equals to minus 180 degree, that you can do, or there is some method 2 where you make the imaginary component 0, and there if you don't get a valid phase crossover frequency, right, if you find the answer solution, you see if you don't get a valid phase crossover frequency, you will not get correct omega phase crossover frequency, right? Basically like phase crossover frequency won't exist. Okay, so that is it. So yeah, this was like the calculation, all those things, few short tricks I told you, right? 10 words about that, all those things. Okay, so yeah, this one. So now let's start our lecture. Sorry, like I have to give you a brief overview, right? Like the previous lecture was a bit hectic, that's why. So yeah, now let's start our lecture basically. So here, right, this is the first question where we have to find the relative stability parameters. So this is the same question for which I found the gain crossover frequency and the phase crossover frequency. So that obviously I will copy right here. I won't again calculate because I will need the gain crossover frequency and the phase crossover frequency for to calculate the gain margin and phase margin, right? Graphically, how we can found, I told you, right? Now how can we find it like analytically and in like written format, right? How can we find it without graphically? So this was that question, right? Yeah, this was which question? Yeah, this one, right? So this was this question. Okay, so for this, what is my gain margin? Gain margin is omega g equals to 4.25 and my phase margin is infinity, right? Why? Because it never reaches, like reaches the minus 180 degrees at omega equals to infinity. So that's my not my phase margin, sorry, my gain crossover frequency is this 4.25 radian per second and phase crossover frequency is infinity. So I'll copy this too. And I will take here, I will write this, paste over here, right? From okay, from which question number? Let me check which question number was that. It was question number 13. Okay, basically this is question number 15, right? And from question number 13 I got this one, right? So from here can I calculate my phase margin and gain margin? So first I will calculate the phase margin. So what is my phase margin? Okay, I would find the relative stability parameters. So calculation of phase margin, right? Calculation of phase margin. So what is my phase margin? So my phase margin, right? Phase margin equals to, what is the formula? 180 degrees plus angle of g of j omega g into h of g omega g, right? This was my formula. So what is my like angle formula? Basically my angle, right, if I take it from that one, or I can directly write it here, that like now we are so like well accustomed with this, I can directly write it over here, right? It is g of j omega g plus h of j omega g, which is equals to minus 90 plus tan inverse omega by 2. Okay, tan inverse omega by 2. So this is what my angle is, right? This is what my angle is. So yeah, this is basically my formula. Now let me find the angle at omega g, right? Sorry, this I have to find the angle at omega g, so I will write at omega g, right? Now let me put the value of omega g, which is 4.25 radians per second. So if I put like omega g over here, so this is like, this will come out to be almost, okay, I will copy this one. Okay, I've already written my like the result, right? It will come out to be almost 15 point sorry, 154.3 something, right? 154.3. It will come out to 154.8 something like that. Just wait, come out to something 154, which is in negative direction, obviously, minus 0.8. okay, something like this it will come, right? So like I hope you have done the homeworks, like you are just cross checking whether your answer is correct or not. So now, right, what is my phase margin? Phase margin is 180 degree plus minus 154.8, right? So this is my phase margin, basically what is it? It is 25.2 degrees, right? This is my phase margin basically. Okay, this is my phase margin. So this is the answer. This is the part 1 basically. Okay, now let's find the gain margin basically, right? Let's find the gain margin. So like this is the amount of angle, this is the amount of phase lag that I need to provide to my system to to my OLTF to take that point to the critical point, right? Okay, to take that where the magnitude of my OLTF is 1, to take that point to minus 180 degree to the negative y-axis. So the amount of phase lag that I need to provide to the OLTF basically, provide to the OLTF to take it to the critical point. Okay, to take it to the critical point, which is minus 1, 0. Okay, this is the amount of phase lag. Now let's calculate the gain margin, right? So calculation of gain margin, right? What is the calculation of gain margin? So calculation of gain margin, right? Basically my GM is inverse of the magnitude of G of j omega p into h of j omega d, the phase crossover frequency, right? I want to make my gain equals to 1 at that point. We have already established this. Okay, obviously we'll calculate this in both log and in normal absolute format. Okay, this is an absolute format, and log also I will calculate. So for what is my this value, omega gc. So what is my omega p? Omega p is infinity. So what is the magnitude at omega p? So if I put omega p infinity, then obviously this one, right? This one goes to 0, obviously. No issue. So obviously my gain would be 0. Sorry, again, if I say gain, just excuse me, it will be just simply the magnitude of my OLTF, right? So my magnitude will be magnitude will be 0, right? This okay, so this is 1 over 0. Okay, hence this is like infinity. Gain margin is infinity. So like in log also, and in log also. So like if you do 20 log of infinity, it is infinity itself. To 20 log of infinity, right? It is infinity dBs. So we can say, right? We can say that the the gain margin is infinity. Okay, question may come and option, there may be some option infinity written over here. You will take the infinity option, right? Because this is infinity is not an issue. Infinity gain margin can come, right? Because we have it is never crossing the 180 degrees, right? At 180 degrees the gain is 0 itself. So any amount of gain or any amount of margin that I multiply with it, it will never come to that -1 point. Okay, what does this signify? This signifies I can never shift this. It can never reach the critical point. Okay, this can never reach the critical point basically. Okay, this is what my gain margin is. So because my gain at the phase at -180 degrees, right? When the angle is -180 degrees, it is 0. That's why. So yeah, this was it for this question. Now let's go to the next question. So what is my next question? So my next question is this one, right? Now for this one, obviously I have to find the gain crossover frequency and phase crossover frequency. Okay, so we can do two things simultaneously. When we find the like the gain crossover frequency, right, or the phase crossover frequency, generally what you tend to do is find the phase crossover frequency because it is easier to find. Now when we find the phase crossover frequency, then we directly find the gain margin from there, right? It is easier for us to find the gain margin because we need the phase crossover frequency for finding the gain margin. So yeah, two things we can do simultaneously. Okay, so this is the what question? This is the 16th question, I think. Yeah, 16th question. So this is the 16th question. Okay, this is 16th question. Then this, right, g of j omega h of, like, I will put s equals to j omega over here. So this is this one, right? So now, like, let's calculate the calculate the phase crossover frequency and the gain margin basically. So let me put this chair here. Crossover frequency. Okay, so this is like, okay, I should do this in the next page. So how to calculate the phase crossover frequency? Simply, right, if we further, like, if we further simplify this one, right, we can further write this one as 10 divided by s into s square plus 5s plus 4, 10 divided by s cube plus 5s square plus 4s. Okay, so this is what my OLT is. Now, like, simply replace s with j omega and I can simply find the phase crossover frequency. Simply the imaginary component would be 0, else finding with the help of angle condition, right, with tan inverse formula will be a bit difficult. That's why we follow this one. Okay, this is much more faster and this is useful for the higher order OLT, right, where the order is very high. So replace s with j omega here. This is like, so this becomes 10 by 5, this is j actually, minus j minus 5 omega square plus 4j, right? So there is this one. So now, right, simply the imaginary component, imaginary part of this one will be 0. Okay, imaginary part of g of j omega p, because it is at the negative real axis, so there will only be real component, not any imaginary component, right? J omega p will be 0, hence the denominator, the imaginary component of the denominator will also be 0. So only these are the imaginary components, right, hence these will be 0. So minus omega cube plus 4 omega equals to 0. So omega, I will take common, omega square plus 4 equals to 0. Again, right, the same thing. That okay, I think I already solved this one. Or did I? Don't remember. Okay, no, okay, this like okay, the phase crossover frequency won't change. I will explain what I'm trying to say here. Okay, once we come to the conclusion, right, we'll see. So this is 2 radian per second. Okay, the phase crossover frequency is 2 radian per second, right? Now what about my phase margin? Basically phase margin again, right? Sorry, what about my gain margin? So we found the phase crossover frequency. Now what about my gain margin? So gain margin simply inverse of this g of j omega p. So it is basically equals to what? 1 by the, what is the value, what is the magnitude basically? So for that I need to write the magnitude also. Okay, what is the magnitude? So it is omega square plus 1 omega square plus 16. So this one, right, this magnitude. So I will put omega equals to 2 over here, right? Put omega equals to 2. So this is the inverse, right? So inverse will be something like this: omega under root omega square plus 1 omega square plus 16, right? So if I put omega equals to 2, what do I get? So basically, right, okay, like you can do it like this one also, that at omega p, right, at omega p what is happening? Sorry, like you can do it like that one also, or what you can say is at omega p obviously my this imaginary component is 0, so in the denominator this part becomes 0. I'm only left with this one. What is the magnitude of this one? Basically the magnitude of this one will be 1 by minus 5 omega, right? P basically. Okay, so it is simply equals to, like there is 10 also here, right? Sorry, there is 10 also. This is omega square, sorry. Yeah, this is omega square also. So omega p whole square, right? So this is the magnitude. So like what happens is this becomes 5 omega p square by 10 itself, which is 2. Hence it is omega p square by 2. Omega p is 2. So 2 into 2 divided by 2, we get 2 itself. So gain margin is 2 itself, right? GM is 2 itself in absolute values. Now what about my in dBs, right? In dBs what is happening? In dBs, like GM I can write in dBs is as 6, right? GM I can write dBs as 6, right? So GM in dBs is as 6. Then basically, like just remember this one, right? You have to remember this, right? Log 20 log base 10 2 is always 6, or you can remember it like this one: log 10 log 2 2 base 10 is always 0.3, right? You have to remember this one. Log 4 base 10 is 0.6, like that. You remember it. So yeah, log 2 base 10. Okay, I will write this one here. Log 2 base 10 is 0.3. These are very useful, handy. In Bode plots you have to use this multiple times. So in anywhere else also you may have to use this multiple times. This is just a square, right? 4 is just a square, so that's how you remember. That's how I remember this one. Okay, these things you have to remember, right? Very useful in gate examination. Okay, so yeah, now if you just simply multiply 20 with this one, you will get 6, and if you multiply 20 with this one, you will get 12, right? That's how you remember, right? And from here also you can derive the other log values also. Okay, so yeah, very important, very useful, right? So I should write here is that, like one thing I should write here is only my real component will exist at omega p, right? That's why I can do this simply, else I have to use that formula, right? I have to use that formula of total magnitude, right? I'm not using it, I'm using the shortcut. Okay, I'm using the shortcut. I'm explaining you all the methods. So let me Like let me reduce the size. So yeah, simply this is 1 over real part of, copy this one. And the magnitude. Okay, only real part will exist, obviously imaginary part will be 0. That's what we did, right, to find the phase crossover frequency. So this is about the gain margin. Now let's calculate the gain crossover frequency and the phase margin. Let me color this differently. Gain crossover frequency and phase margin. Okay, so these are these two. So now right now, like for gain crossover frequency, it is a bit difficult. Just have to find the magnitude, right, and put it equals to, there is no shortcut here. That's why this becomes a bit difficult. Again, right, we get a cubic equation. Again, I've solved the equation, right, like in website, like in online, but like with calculator, obviously you won't be able to solve it by just handwritten calculation, right? So that is very difficult. That's why they will there are 99% chance that they will not ask this. 99% chance they will not ask. 1% chance is there they will ask. But then, right, you have to think through your bed, if think through your brain head, that if they ask this, like you have to find the what, you have to find the roots of this cubic equation, right, third order equation. If they are asking you to find the roots of third order equation, then definitely the root will be something simple, like plus 1 minus 1, minus 2 plus 2, plus 3 minus 3, or 0. So you you use the hit and trial method, and from there you check whether these are my roots, right? So it is very important. Okay, so okay, so yeah, that's how you do it. If they have asked you to find the gain margin, the phase margin or the gain crossover frequency, right, of a third order, basically this is a third order equation, right? Order is 3. If they are asked you to find, you will get 3 roots, right? Hence what you will do is basically you will put few standard values like plus 1 minus 1, all those things, right? Then you can see that, yeah, I'm getting the value, because then only you will be able to solve it handwritten. Else solving cubic equation handwritten is very difficult, right? Manually is very difficult. You have to use online calculators, all those things, right? So yeah, I have also used this. So what does this equation become? So at omega, at gain crossover frequency, what happens? My gain is 1. So I will copy this one. Gain is 1. So my gain is 1, then what happens? Basically this one will be equals to 1 itself. This one will be equals to 1 itself. So if this one is 1, so this is omega g, this is omega g, this is omega g, right? And also if this one is 1, what I will do, I will square both sides, right? And I will put omega g square equals to 1. So sorry, omega g square equals to x. I will name another variable, omega g square equals to x, and I will square both sides, right? If I square both sides, what do I get? This is 100 divided by omega g square equals to 100. Omega g square equals to 1. Okay, so yeah, sorry, have to replace this x. So this is this one, right? This is this one. So now, right, now let's solve this equation. So I will take this that side. So x square plus 17x plus 16 equals to 100. So it is x cube plus 17x square plus 16x minus 100 equals to 0, right? So obviously there will be few negative solutions. I will ignore them, and the solution that I will get, I've already written it down here, right? So my solution, I've already written it down. So it is x equals to 1.915. okay, and I'm ignoring it's 1.915, right? Yeah, ignoring the negative solution. Okay, so ignoring the negative solution basically. So if I ignore the negative solution, I get something like this one. Okay, my x is 1.9. So what is my omega g? So my omega g equals to under root x. Okay, obviously I will take the positive solution. So if I do under root 1.915, I get around something 1.84384 radian per second, right? So this is my gain crossover frequency. Okay, now what is my phase margin? My phase margin is basically 180 degree, like as we did in the previous question, right? It is g of j omega g into h of j omega g, right? So this is what my gain margin is. So simply, right, it is like, what is my angle formula? Okay, I have forgotten to write the angle formula. I will write it directly here, or we can write it here also. This 15, yeah, this 16. Okay, this is the magnitude one. Can I write the angle one also? Let me now do one thing. Take this. Okay, sorry. Minus 90 minus tan inverse omega by 4, right? Okay, so let me copy this one, and instead of omega, what I will do, I'll put 1.384. okay, let me check if it is recording or not, else it will again be problem, right? So yeah, this is recording, no issues. Okay, no issues, this is recording. So sometimes I get like frightened, right? Like I get like, what happened if it is not recording? Then again I have to re-record. That will be a task. So it is 1.384. okay, so this is this one. So like if I do tan inverse this one, right, all this I've already written it down directly, right? I have, like, this is for your part, you have to simply put this in gate calculator and you calculate, right? No, like nothing like different I will do. So I will get my phase margin. I've written down the results. I will get my phase margin as 9.6 degrees. Simply just put tan inverse in the gate calculator. One day I will also show you how to use a gate calculator also. It is very important to know how to use a gate calculator. So simply if you put the value of tan inverse this and 1.384 by 4, you will simply get phase margin as 9.6. So this is the amount of phase lag that you have to provide for it to reach the critical point, right? So yeah, now let's solve for the 16th question basically. Okay, no, the 17th question, sorry, the 17th question, right? So yeah, let me copy this one. So like I will just copy this pattern, because so first like let me break it down. Okay, the denominator things will be different, so I'll just simply copy and paste this one. That is fine. I can simply copy and paste everything actually. So what I will do is simply from there we can solve it. So what I will do is I will just change this one. So what I've done is simply change the numerator, right? Numerator is absolutely same. Okay, so what I will do, I'll just change the numerator. Okay, it's easier for me. Obviously you have to do it again by yourself, right? This is 17. Okay, and this is 20, right? This is 20. So this numerator changes to 20. Now is there any difference? Let's see, is there any difference? So this one changes to 20, right? This one changes to 20, but the denominator is still same, right? Nothing change, just the gain will change, right? The gain will change. Okay, gain will change. And again here, right, like we are calculating the phase crossover frequency and gain margin. So tell me will the phase crossover frequency change? If you said that will change, then you're correct. No, you're not correct, right? Because phase crossover frequency depends on this denominator, right? And just we have to make the imaginary component 0, or what you can think as phase crossover frequency depends on the phase. And does phase depend on the magnitude of the numerator? Okay, does it depend on this? Okay, no, it depends only on the poles and zeros, right? And poles and zeros are same here. Right, we don't have any zeros, and poles also are same. Okay, that's why my phase crossover frequency will not change. Will my gain margin change? If you said it will change, if you said it will not change, sorry, you are wrong again, right? If you said it will not change because you think, yeah, it's depending on phase crossover frequency, right? It is depending on phase crossover frequency. If phase crossover frequency isn't changing, then my gain margin will also not change. No, why? Because my gain margin includes the numerator also. Okay, the real part also. Okay, the real part of g omega. Here, right here, there is numerator. That's why my gain margin will change, right? But for phase margin, basically I'm making the imaginary component 0. To make the imaginary component 0, what I'm doing, just taking the denominator. Okay, but during real component I'm considering the numerator also. Okay, so I hope you get the point. Just making the imaginary component 0 here. In the numerator I don't have any imaginary component, that's why I can ignore this one. But during the real case, right, in the numerator I have a real component. Okay, that's why I can't simply ignore this one during the real of g omega, h of g omega, right? During this point, that's why I didn't ignore the numerator. But here I ignored the numerator because my imaginary component are present only in the denominator. Hence I am concerned with only the denominator. Okay, I hope you got the point. So my gain margin will change. Because this numerator has changed, right? So this will become 20. This will become 20. Okay, and again, right, all of this is same. Nothing changed, right? Because my denominator, I'm just making the denominator imaginary component equals to 0, right? And this is real component, and this is basically 20. Okay, and yeah, this is this one. So this time omega p square, so it is omega p square, there is into 2 also here, right? Into 2, because this is 20, right, not 10. So sorry, what I did wrong here. This is divided by, okay, this is wrong. So this will be basically 5 by 20. So this will be 4, right? Omega p square by 4. So my gm, right, gm becomes omega p square by 4. So this gm becomes 1 itself. So what is log of 1? Log of 1 is 0, right? These things you have to remember. Log of 1 is 0. Okay, so 20 log of 1 is 0 itself, because log of 1 is 0. 20 times 0 is 0 itself. Now what will happen to my gain margin? So sorry, what will happen to my gain crossover frequency? It will definitely change, because it is depending on the gain, and my numerator has changed. So this will definitely change. Okay, so what will happen? Like this is 20. So if I square on both sides, all these are same, the procedure is same, just this numerator will change. If I square both sides, this will become, instead of 100, this will become 400, right? So this will change. Okay, so if this changes, right, if this changes, basically like this value will change. Okay, this value will change, right? and this will also change. Okay, all of these will remain same, all of this will remain same, right? So this time, right, my root is simply 2. Why? Because already I have calculated this one, right? This exact transfer function OLTF, I've already calculated this one. Okay, in the case, like in the previous question. Okay, let me like tell you from where. Here, right? Yeah, here. Yeah, this one, right? This one. What was the question of this one? Question number. The question number was simply where is it? Where is it? Where is it? Where is it? It is 14, right? It is 14. So from 14, I can say that my omega g is 2 radian per second. Already calculated this one, right? Omega g and omega p are same, 2 radian per second. Okay. So yeah, from question 14. Basically. Okay, so yeah, this is already calculated. So my x, right, sorry, like omega g is 2, sorry, omega x will be 4, sorry, so omega g will be 2 itself, right? Omega g is 2. So like this, right, this will simply become like what do I say? So this will simply become tan inverse 1. I will say like this will simply become tan inverse 2 divided by 1 by 2. Now do you know the trick? I've already told you, right? Tan inverse x minus, like tan inverse x plus tan inverse 1 by x is 90. So this whole thing will contribute minus 90, right? Because minus is in common, and this is also minus 90. So overall, right, my phase margin will go to 0 degrees. Okay, like 90, and this is 90 also. Okay, tan inverse x by tan inverse 1 over x is 90 degrees also. Okay, so overall it will go to 0 degrees. So my phase margin is 0. I don't have any margin left. Okay, so I can say my head is a bit crashing. Like I don't have any, no margin left. Okay, no margin left. So I don't have any margin left, right? So if I don't have any margin left here also, it is 0 dB, right? So no margin left. Basically, if it is one unity, right, I don't need to multiply anything. Simply it is already at that point. Okay, no margin left, or 0 dB represent that I don't have to add anything, add any dBs with it. Like whenever I multiply, right, if you want to, like if you want to convert this into addition format, simply convert that into dBs. That will be simply addition. Addition in dBs, addition in logarithm means multiplication in absolute values, right? Like log a plus log b equals to log ab, right? Ab is the absolute value, right? So yeah, no margin left. So what does no margin left means, we'll understand firstly. Okay, so let's now do the third example basically. So what was the third example? So third example was this one, right, where I had 30, right? I will again copy this whole thing. Okay, I will copy this whole thing again, or I can simply paste it, or can I? So this will become 18 now. Okay, .30. So this will change to 30 again, and this one, this time I haven't done this one, right? Previously this one will change to 30 again, right? What will change? Will my phase cos or frequency change? It will not change, right? Because it is depending on the angle. Okay, and if I change the just real part of my numerator, then it will not change my angle. Angle is dependent on the poles and zeros, right? So yeah, poles and zeros are still same, right? So this, right, again, right here, is the angle changing? No, angle is still same. Angle is still same, right? It is not depending on the numerator. So angle is same, right? So my angle is same. So this will become 30, right? And this will become 30, okay? And if I make the imaginary component 0, still I will get same omega p, right? And now let's do the gain margin. So gain margin will change, right? This will become 30 here, right? This will become 30 here. So this will be 5, okay, 5 omega p square. So it is omega p square by 6. So it is simply 2 by 3, right? Simply 2 by 3, okay? So this is what my omega p square becomes, right? Like this is what my GM becomes. So GM is 0.67, okay? Sorry, okay, I write it over here only, okay? 6 square by 6. Let's change it in the previous question. Yeah, I changed it, okay, fine. So this is my omega, where did I go? Yeah, this is my omega square by p square by 6. So it is simply omega p square by 2 into 2 by 6 itself. So it is 4 by 3. So it is 2 by 3, which is equals to 0.67, right? 0.67, okay? So it is negative. This time it is coming negative. So I've already written it down. So in dBs, right, this is something negative, okay? This is not positive. Minus 3.48, minus 3.48 dBs, okay? So my GM is coming negative. What does this signify? What does this mean? All this will understand, right? All this will understand when we will do the comparison. So my, obviously my gain crossover frequency will change because the DC gain of my OLT is changing, right? So this is 30 because like it is dependent on the numerator also. So this becomes 30 this time. This becomes 30 this time, and this becomes 900 this time. Okay, and if this becomes 900, this also becomes 900, and this, right, this also becomes 900, right? This also becomes 900, okay? So like what does my roots this time is? My root obviously is changed this time. So I have already calculated it. My root becomes something around 5.926, okay? The root is around 5.926. So like again I do the square root of this one, right? So square root of 5.926 is almost something 2.44, something like that, almost 2.44, right? So it is almost 2.44. Now what is my omega GC? My omega GC is like something like this. So I will replace this one with 2.44, right? 44. So what does my this become? What does my phase margin become? So if I put omega GC equals 2.44, then obviously this, right, this will be like 90 minus, okay, okay, not minus of, take common, tan inverse 2.44. I've already written it down. It is something around 67.67, right, around that degree. And this is also like this, right, this is around like 31.32, okay, 31.32. So around, what is the angle that I get? Like already calculated it. So it is around minus 9 degrees, right? Minus 9 degrees. So what does this mean? This means it has already crossed my 180 degree. I don't need to again make it, like I don't need to add any phase lag. No need to add any phase lag. Okay, no need to add any phase lag. It has already crossed. Already minus 180, right? Already was my 180 point. Okay, So this is it for phase margin. Now, like, this is the end of this lecture. What I wanted to do homework is, obviously, I think if you get the notes, you will see it already. But do it for yourself. You complete this table, right? You complete this table and see what is changing and what is not changing. Like stability, for what values of GM and PM it is stable, for what values of GM and PM it is not stable, if its margin is stable, all those things, right? You see here and do it for yourself. Complete the table. I will complete the table and we'll start the next lecture and understand like more about the gain margin and phase margin, right? Okay, and also do few questions. Okay, so yeah, the relation between the omega GC, omega PC, gain margin, phase margin, all these things we'll do in the next lecture. So yeah, I hope you like this lecture, and if there is any doubt, obviously put it down in the Telegram section, like in our group. And thank you for watching, and I will see you in the next lecture.